Let me introduce Sandra Brantingham to you. She's been interested in astronomy from an early age. She's worked in the RAF for many years, where she saw lots of different skies around the world. She joined Sigma, this club, and has been its secretary. She was appointed in 2003 Aurora and NLC director of the SPA, and she took over the same job in the BAA in March 2016, and she's now in both of those posts. She runs another small group of astronomers in Huntly, near here. She lives on a 10-acre croft, 57 degrees north, so she gets a lot of aurora there, except that it's cloudy quite a lot of the time.
Yes.
And but she still enjoys it, and
absolutely,
and it gives a great deal of pleasure to enthuse people about what they can see in the sky. So take it away, Sandra.
Thank you very much, David. Right, hopefully this won't explode when I press the button, so here we go. Noctilucent clouds. When I first joined the BAA, I actually managed to change the title of the thing from Aurora to Aurora Noctilucent clouds, because it's a very important part of what we do. So I'm Aurora Director and a council member for the British Astronomical Association, and I also do the same job for the SPA, and I've done that for 16 years, so lovely job. Right, so the plan, this is what I plan to tell you about. Its history, what it is, the atmosphere, the mesosphere, where and when to see it, and that's changing all the time. What fuels affects it, and there's arguments over that. How do we track it? What types there are. Tonga, for those who don't know about it. Camera operations, because those can be quite fun. And a final plea to stop me and Ken tearing our hair out. Right, so can you all hear me at the back? I know I'm a noisy piece, so there you go. Right, let me take you back to May 1883. Most astronomical stuff, you can go back millions of years, so certainly records go back hundreds of thousands. Noctilucent clouds go back to 1883. And in May 1883, an island in the Sutras, let's see, I'll get this right, the Sundra Strait between Java and Sumatra, called Krakatoa, started to erupt. It threw up bits and pieces, it blasted lots of stuff into the air, and then it seemed to settle down. The Dutch, who were in control of it, went across to have a look at it, and there was one guy who was really, really keen, went to have a look at the damage and the debris. He actually saw what we now know as pyroclastic flows down the side of it. But we didn't know that at the time, and the studies of this basically kicked off volcanology. But he had a good look at it and thought, oh yeah, that's fine. Came back. Trouble is, the problem was not over, and Krakatoa had half emptied the caldera. It then started to fill with new magma. Now, I don't know the ins and outs, but basically the mixture of old and new magma caused it to blow. And on the 27th of August, 1883, it blew with tremendous force. This is what happened. The shockwave went around the Earth 7 times. So how do we know this? Well, the Victorians were actually ready for this. They were into sky, the clouds and things like that. They were buying up all sorts of instruments. They were ready. So when Krakatoa went, the Victorian era actually knew about it. They watched the stars. They didn't have light pollution like we do, you know, so they really were ready for it. The tsunami it created was 40 meters high. We know this because there was a ship in the Sundra Strait at the time that actually turned into the wave and made it. But when it hit the land, it was killing thousands and thousands of people. So it made an absolute mess. It is supposed to be the loudest noise in recorded history. It was heard thousands of miles away. And as I say, it kicked off volcanology. It kicked off something else as well. Now, when I was very young, if I was good, not very, very good, that's another story and leaves to tidal forces, but if I was young and I was good, they used to take me into Backhouse Park. Now, I thought Backhouse Park was because it was back of the houses, but it wasn't. It was from the family of Thomas William Backhouse, and he was an avid meteorologist. He loved watching the sky, and Krakatoa gave everybody brilliant sunsets round the world for about 2 years. It was absolutely fantastic. What else happened was something else appeared, and in 1885 he noticed a new type of cloud. It appeared after the sun had set. It was really bright. He had no idea what it was, but he logged it. He made a note of it. And as far as I know, this is the first recording. There are arguments, you know, somebody else might have seen it later on, but published it earlier, but his is the first one. It was seen a few days later by Otto Jesse in Berlin. Now, this is the sad part, as far as I'm concerned, because he then gave up, whereas Otto Jesse continued to observe, and he actually opened up the study of noctilucent clouds. So it's a modern basic discovery. Noctilucent clouds have not been going for that long. So in geological terms, it's almost brand new, effectively. And therefore, when something happens, we're not quite sure what's going to happen again. And you'll see that later on. So what is it? What are we actually looking at? It's very, very small particles of dust. Their ice crystals form on this dust. And it's lit by sunlight. Now, the point of it being, it's lit by sunlight when you can't see anything else. And I'll come into the actual descriptions of why. But particle size. Now, this is David Rees. He's got brilliant gear, and he's got this LiDAR. And this is this year. He was after effects in southern England. So particles are up to 100. That's not nautical miles. That's nanometers, right? Okay. So they're not big. They're tiny. These are not asteroids, you know. So they're tiny particles. They're highly reflective of radar in the 50 to 1.3 gig. Era. They can be detected by LiDAR, and this is David's detection this year. And he was down Middle England, and this was his first belt at it. So we're hoping to coming in. Now, why are they detected by radar? They're possibly caused by sodium and iron atoms. This is a bit of an argument at the moment. However, there are studies that indicate that sodium atoms decrease in the thermosphere when the clouds appear. So it's not guaranteed. I mean, I haven't got Richard Branson yet to go up and fly through it, but it's pretty certain that that's what's causing them to be very radar reflective. So let's have a look at where we are. Now, for those who don't know this is basically the atmosphere, and the atmosphere is divided basically into 4 parts. The reason being temperature. What happens to the troposphere? Troposphere is where we all live, right down here. Everything we do, nearest damn it, 99.9%, flying, balloons, you name it, all happens down here. You go into the stratosphere and the temperature actually increases. So that decides it, and that's basically because of the ozone layer. You go next to the mesosphere, and that's the bit I'm interested in. And that basically runs from 50 to 80 kilometers high. It is, I'll go into the details of it later. Above that, the temperature increases again, but you wouldn't feel warm, right? Don't say, oh, it's nice and hot up there. It isn't. The atoms are so far apart, you wouldn't notice it. But basically, the temperature increases. So let's have a look at the mesosphere. And mesopause, if you ever hear the word pause, it means edge of. So in the previous talk, you heard heliopause, edge of solar system. Mesopause, edge of, top edge of the mesosphere. It's 80 kilometers or 50 miles high. We've actually measured at about, what, 82, 83, somewhere around that. Most measurements come up at about that for the clouds. It's cold. It is the coldest point of the atmosphere. And you'll see later that the temperatures do vary, and it's the cold that's critical for Noctilucent clouds. It's very dry. If you think the Sahara's dry, this is 1,000 times drier. It is the driest place in the world. It's very difficult to get there or stay there. Balloons don't reach it. Rockets go through it. Well, like rockets, you know, gone. Like I said, Richard Branson, if he launches, he goes up to about 100 kilometers and then he floats down. So if he ever comes down there, I'm going to get him, ring his ear, say, "Oi, you know, any chance of a sample as he come back through?" But it's also, the mesosphere also had a designation called the unknownosphere. In other words, we don't know a lot about it. We know more, as Claire says, we know more about the sun than we do about the mesosphere in that zone. Ridiculous, but there you go, that's the way it works. So, Noctilucent clouds, you can see here on the left hand side is a graph of temperature, and the temperature is dropping from May through to June. So you've got a massive drop in temperature. At the same time, you've got a massive rise in moisture. Now these are all different years up to 2020, but you can basically see as the temperature drops, the moisture level rises and gets to the point where at about here, Noctilucent clouds start to form. This occurs, right, I'll go further. So when and where? Between 50 and 65 latitude. Now you'll notice I put a question after 50, and you'll see why later on, but they are spreading south. After sunset, when the sun is 6 to 16 degrees below the horizon. Now, I've been watching them, and as the sun rises, I've actually held it to 5 degrees. But I would say that if you go out and look and it's 5 degrees, you won't see Noctilucent clouds, or you won't think you have. But I've watched them and I think, oh, I know that's a Noctilucent cloud because it's just disappearing as the sun overdrives it. So it gets lighter and lighter and eventually they disappear because they're very, very tenuous. From late May to August in the north, I'll go on a bit about this season later on, but you're looking at, let's see, 50. We normally have a thing going between me and Ken as when it's going to start. So it's between the 15th and the 25th of May. Normally we kick in, and you look at the Ames satellite. From November to February in the south. Having said that, it didn't kick off until December last year because of a problem with the winds down there. And as soon as the winds changed direction, it fired up. So we're watching that like a hawk. What fuels affect it? And this is where it gets controversial. Volcanic eruptions. Well, it was kicked off by Krakatoa. There's no two ways about that. What Krakatoa did, we don't know for certain. Did it change the dust? Did it change the temperature? What did it do? We do know that certain zones like the stratosphere and the mesosphere are almost fixed. So any damage to them tends to be permanent or go on for a long time. Man-made NLCs from rockets. You can see a rocket trail here, and we've seen this many times. The space shuttle was horrendous for dumping stuff in. And right now, the amount of rockets going up is incredible. So the amount of stuff being dumped into the higher atmospheres, i.e. the mesosphere and the thermosphere, as well as the stratosphere, is incredible. Meteorite smoke, definitely without a shadow of a doubt. That will create lots of bits and pieces. We get, was it 200 to 500 tons a year? So at least, so that's falling in all the time. Global warming, climate change. This is almost like a dandy, or the canary down the pit. This is probably tell us before things go wrong, when things are going to go badly wrong, because if they go wrong up there, we're going to be in real trouble down here. Real trouble. So how do we track it? Well, there you go. This is the Ames view of NLC. That was June 2020. But there she is. That's the lovely satellite. And Ames aeronomy of ice in the mesosphere. It's basically got 3 cameras on the front of it. And those are it was launched in 2007, sorry. Guess how long it was going to go for? 26 months. This is going to last 26 months. It is still going strong. However, as I was explaining to somebody, this is like the Battle of Britain, and that's the radar. If that goes down, we're back to the observer corps. That means all you lovely people, and we will be relying on you. But this gives us a lot of warning. There are problems with it, and I'll explain that to you later. But the main instrument, and Cora Randall looks after this and keeps us informed nicely, is the cloud imaging and particle size. So if you hear us talking about SIPs, that's exactly what we're talking about. It's 3 cameras. Basically, it looks down and it does odd scans and stuff like that. It creates what we call polar daisies, if you've never heard of that. It's on space weather on the left-hand side, normally about 3/4 of the way down. Or you can go to the side and you can see each daisy in turn over the years. There it is, kicking off this year, 22nd of May 2022. Just firing up these little bits here. We're on, you know, game's afoot. Right, June was great. July was rubbish. A, because of the weather, but B, and Ken just showed me the diagram today, the temperature actually increased before decreasing again during July, cutting down. But this occurred in the 10th of August. Now, we get these about 3 to 4 days late, so it only tells us what we're doing. It rotates in about 5 days' time, so it's after the event. But on the 10th of August, we got, this came all the way down here. I had Bill Ward on, you know, sort of saying that this is the best NLC I've seen. We were getting actually reds in it in the mornings, so it was absolutely beautiful. The other thing I want you to notice is these sharp edges here. In other words, it's cutting off, so we're not seeing the full extent. As Ken will explain to you, it's our observations that have enabled them to change the algorithm to extend it, but there are limits to how far that camera can see, and therefore your observations are still critical, very, very critical. So you can see it from space. There you go. This is from the ISS, but they've got so many jobs, they only take the odd picture every now and again. So what types are there? This is the standard one, and I've had a lot of people saying, I might have seen Noctilucent clouds, but I'm not sure what I'm looking at. So now I don't know if I've got it in here, the patron saints, but if you can see Capella, right, you've got a star, you're probably on. You're looking for something really bright. If you've got a little sky chart, make sure your sun's 6 degrees below the horizon. This is bright. This is not like the Aurora. The Aurora kicks off its own light. This is reflecting sunlight. So it's like trying to take a picture of the moon. It normally overdrives it. This is bright. And the modern I was going to say, I'll do the camera ops later. But your latest phones can go click and you'll get it. Yeah. But you've got these lovely, I think it's almost like when you go underwater and you look up and you can see the ripples. But it's called fish bones, mare's tails, you name it, but it's classic NLC, the ripples. You've got bands. Now these can be mistaken for jet trails, except for the timing. So if it was late at night and it was a jet trail, it would be orange or you wouldn't even see it. But these are big white lens. And you can actually think, oh, that's a jet trail. Hold on a minute. It's midnight, you know, you can't see it. So they look rather strange. There's got waves, and you can also see other things starting to occur, whirls. It also seems to depend where you are from. So the angle you see it from will vary what you see. So you might see the fish bones, but you're looking up. As it comes down, you get other effects. So it's basically like a corona, but you don't actually get a corona. You know, it's just the optical illusion of it. But any photographs are good, and anything sent in. I said 50 north. Rafa sent me an email saying, look what I've got. Valencia, 39.5 north. That was last year. There was another one, I think, another degree south, but they were higher up in the mountains. But it's spreading. It is certainly spreading south. How are we doing for time? Oh, that's all right. Yeah. So, Tonga. Anybody heard of Tonga? Yeah? Right. I'll go through this slowly so you know what you're looking at. At 0410 UC, on the 15th of January, there it is, just blasting. By 0420, it's going through the stratosphere. By 0430, it's reached the mesosphere. It's a massive blast. It's a steam volcano. It then collapses and you can see the marks of the stratosphere. That's the distance across, but it reached 53 kilometers in height. It's the highest volcano we know so far in modern history. What it's done, and this is just a recent update, so I'm talking about 3-4 weeks old. I'm not going to, like Nick, I am dead against this new SI unit called Olympic swimming pools. But it has increased the content of water in the stratosphere by 10%. Now that is massive. I mean, geologists go on, meteorologists go on about increasing by 1% is big. This is huge, absolutely huge. It will stay there for years. As was explained in the talk last night, normal volcanoes with the ash and cloud can fall out, you know, quite rapidly within weeks or months. Water vapor stays there for years. Also, ash clouds tend to reflect and cool down. This heats up, and we're already now seeing, and I saw this 3 or 4 days ago, a map where shows in the Pacific area temperature increases of quite large builds and bounds. The problem with the stratosphere, as was explained to me, was that it's like what they call an alarm clock. In other words, it's ridiculously stable. This has destabilized it. So what happens down south in November, I'm going to watch like a hawk because it's going to be fascinating. It will probably cause warming. It will definitely cause warming, and it will do it for years. So, how are we doing? Oh, nearly there. Camera ops. Right. This is the camera I had, and I used to take Noctilucent clouds with. But as I said, if you've got a modern camera or a modern phone, you can just go click and you'll get it. Right. Notice a dark, they painted black, and then they make these tiny. So make sure you know all the bits and pieces. And we've all been there, you know. Then you go to manual and this focus goes out and things like that. The amount of out of focus pictures I've had, you would not believe. Mind you, also the amount of observers who, shall we say, reach my age and their toilet requirements make them observers, because as they walk to the toilet from the bedroom, they look out the window. Oh, I saw Noctilucent clouds. So it's quite good, but keeps them going. So let's have a look at this photo. There's Comet Neowise, Noctilucent clouds, normal clouds lit up by the black, but also street lights. This is Sheffield, right in the middle. I had the last sort of FOMO from Glasgow say, I can see them. You sent an alert out. I opened my windows and there they were in the middle of Glasgow. So there's plenty of light. So not like Aurora to struggle to see. They are easy to see. Right, and there you go. Capella, patron saint of Noctilucent cloud watchers. And it's in lots of photos. I've seen it millions of times, haven't we, Ken? Right. This is Noctilucent clouds and Aurora. It's only the second time I've got it. This was the first time I caught it, 2016, I think. And basically, I was taking pictures of the Noctilucent clouds, and I was on about a second exposure. Oh, there's the Aurora. Turn the camera, click, nothing. 2 seconds, click, nothing. 5, 10, 50. I got to 25, and there it was. Yes. But look what happened to the Noctilucent clouds. They've overdriven. In other words, there's a massive difference between the amount of light, because that's reflected sunlight, and that's self-generated light. So, but I've got it. I did it. You will only get that at the beginning or the end of season. So you're looking early May or August, somewhere between 5th and 10th, or something in that neck of the woods. The problem is up here, it's often too late, July, June, to get, as you know, Dennis, to get Aurora on anything like that. Mary McIntyre maddened me on the June the 21st, showed me a picture of the Aurora, because it's further dark, it's dark. And if you're well down south, down in London, yeah, you'll get the Aurora. You get it from Nick's place, but you won't get it up here. Okay. So a final plea. There you go, Nick. To stop myself and Ken going absolutely mad, send in your reports, yes, but please write your full name. You wouldn't believe how many Bills or James or Jeans I know. Say where you were, the town, you know. You might have been on holiday, we don't know. Double date it so at least we know the night that it's going on. And stick a picture and attachment. Send it to that, or if you've got Ken's. But my address is in the back. I'm wide open. It's in the BAA journal. Contact me Ian anytime. No problem at all. Thank you very much for your kind attention.
Thank you very much, Sandra. Anybody got a quick question?
Yes, Nick.
I've just got to add to what you just said. In the summer, can people please try and make sure that they say whether the time they quote is GMT, UT or DST?
Yeah.
That's really a problem. The other thing is if you're taking pictures with a DSLR or any camera, it's always good to regularly reset the clock on it. So, not just for NLC, but for everything. We get pictures of fireballs and meteors where people haven't reset the clock on the camera since they bought it. So don't know whether it's GMT or BST, and it's an hour out anyway. So, yeah, if you're doing any astronomy, you never know what you're going to get when you take pictures with your DSLR. Please, please, please get that clock right.
Well, unfortunately, if I don't accept any images of time unless it's taken selfie. Whatever.
Yeah. Yes.
No.
And if you do get something important there, you're not sure what the time was, don't go and reset the time on your camera. Take a picture of a clock with the camera with the time that it currently is, because then we can work out what the offset time is. If you change the time, we've lost that information for good.
Yes,
Sandra, when you get the pictures on your computer sent in to you by Observer,
Yes.
are you doing any measurements on them? Because you were saying before that you were tracking these changes. Are you actually doing measurements on the photograph?
No. What I'm tracking is the actual Noctilucent cloud mass itself. That's what I track. I know Gordon and yourself and others are doing variations of doing height and things like that. I'm not into that as yet. So, but if you want to have a go at it, go ahead. Yeah.
Is that what you do, Ken? Are you doing anything?
Height is measured by LiDAR, not by the space.
Yeah.
It used to be important for two stations, and I still take pictures on the hour, 4 hour, half hour, quarter to position. That's what I do. Having done that, I've got one or two pictures taken at time D. It takes the same time when I cross mile up the lower third within a minute. And you can then see the difference of Capella compared to some of the features of NLC. We don't use nowadays photographs to do height measurement.
What I'm asking you, Sandra, is are the photographs that are sent to you, all these Noctilucent cloud pictures, are the pictures which you get any information out of, or are they just pretty pictures?
We get the idea is to get the information and to store them. So if somebody wants them further down the line, they can go to the university and say yes. But basically, they can tend to be pretty pictures, and a lot of them are actually. You know, when you get them, you think, no, this is an artwork. You know, I mean, it's designed to go, you know, sort of look pretty. The actual bits and pieces. A lot of what we do as directors, as you know, Nick, is for historical. So we are sort of picking up what's happening now. So somebody in the future can look back and say, yeah, this is what happened. This is what they saw. This is how far it goes, and that's the big thing Ken goes for, is how far south it goes, and if it's moving further south, which it appears to be.
Pictures are not with the I'll do comparisons between people's pictures to see the form that's taken and the positions they can tell and relate to that. But the important thing is to get these, as Sandra said, the date and time of patients. These are really important. If I compile the data every year, I tend to control randomly. If you use this in comparison with the similar, if you know that the film itself is not the film and so on things, you do answer.
And she actually adjusts things and stuff. So we work as a team basically, don't we? So yeah. Yeah.
We weren't seeing MLC so far, so we were seeing overhead. Obviously, we're seeing overhead at 50 north. That's the latitude of that. They weren't seeing initially, we were at 60. So we're seeing our clock coming in. Well, we obviously see further south. We keep the Elgin below the symbol of the income, right? And the first thing you cut the clock into the bottom is to do with the light reflections going. Don't get rid of that. The box that we're seeing now, roughly, is the latitude of the system. The head becomes comparable.
So I won't tell you about the panic. All right, I'll tell you about the panic bit. I always watch the Daily Daisies. For some reason, it stopped on the 31st of August, and there was still a bit on it. So last night I went to the main store for them, and the last one was 31st of August, day 243. Ken and I don't think they normally keep going. So why they've stopped, we don't know. Because I'm normally sending out an email to all of you saying it's over, you know, this season over. At the moment, I don't know. I can assume it's over because there was hardly anything on the 31st, but we don't know why. We're trying to find out why at the moment. If we lose that, we're in problems. Yeah. We are really in problems.
Good. Well, thank you very much.
Tim.
Would you say that pictures taken with all side cameras are more useful or less useful?
Equally, quite a few. I mean, Nick will proudly say, I don't take any pictures. I go to bed and the cameras get blasted away. But quite often, Nick's is the furthest south, you get Chelmsford, you know. So if we get them, we're in for it. We want to see how far it goes so we can get the satellite updated and stuff like that, get Cora updated. So that's the main thing. So any information is good information. I mean, if you want to make them look really nice, that's fine, you know. But stick to those, please. As Nick will tell you, it's
Yeah, I've seen the NLCs twice this year. On one occasion, it did go overhead. That's from London.
Yes.
I've only seen that once before.
It can do that, and it's quite spectacular. And well, if you're getting it down in Spain, the big thing, of course, is because it's 6 to 12. I won't be able to see it, and I'll get phone calls from London say I can see it, and I say it's too light here. The sun hasn't gone down low enough, you know. So basically, the band moves up and down the country like that, and then it disappears down, and it just vanishes, and then it's gone.
Yeah, I'll look it up and send it to you.
Yeah.
Right. Okay.
Thank you very much.